Hey everyone, today we are going to solve longest substring without repeating characters. This is a most famous question. As you can see, it has been asked by a lot of companies, especially Amazon and Apple. So yeah, let's get started. Given a string S, find the length of longest, let's time ourselves to. Given a string S, find the length of longest substring without repeating characters. So A, B, C, A, B, C, B, B, A, B, C, A, B, C, B, B, 3. The answer is A, B, C with the length of 3. Okay, the given string is find the length of longest substring without repeating characters. Okay, so A, B, C, A. Okay, I got it. And B, so as soon okay, A, B, C, then D, then P, W, W, K, E, W. So KW would be the one. Longest substring is a subsequence, not a substring. Substring meaning so here we are given a string, so we have to find a substring which is the longest substring, which doesn't have any repeating characters in it. So once the repeating character is there, then it's no longer a substring. Okay, so this is a classic sliding window problem. What we can do is we can have a and start window and an end window here at the starting point, and we can just increase the start window and keep a count of um, alphabets that we are encountering. And as soon as the alphabet count goes up, alphabet which we have encountered before appears again, then we have to uh, move this counter, decrementing the number of subsequent, like number of alphabets that we have encountered. And as soon as the number of that encountered alphabet goes down to being 1, then we can continue our search. Then that start window stops, and then sorry, the end window stops, and then the start window could move again. I can draw this in the mirror and show you better what I'm trying to explain. So we have, okay, this is 2. Okay, yeah, this is better. So A, B, C, A, B, C, B, B. Have this guy, right? Let me refresh this so we can see the updated one. Come on, up here. Okay, I cannot see. Okay, Am I on the same page? Okay, that's what I don't like about this. It's thinking it's saying that 22 seconds. Okay, no worries. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, I found. Yeah, this looks good. And then what we'll do is we had A, B, C, A. Let me. Okay, okay. So we have A, B, C, A, and let's go here. B, C, B, B. Okay, yeah. So let's say 2 pointers are here. The start and end will keep a hash map. Keep a hash map where it will have A, like when it. So green arrow meaning uh, it's on. It's a start index. So it's pointing at A. So we'll update the A counter to 1, and we'll move the start to B. So B will get updated to B will be encountered and B will be updated to 1, and then we'll move the counter to C, and C will be encountered and C will be updated to 1. Then move the counter to A. Sorry, A. As soon as we move the counter to A, the value of A will get updated to 2, and we are checking um, we are checking the element for its uh, for its frequency count. So as soon as the frequency count goes above 2, goes above 1, we will stop the start counter and we'll start with the end counter, and end counter will look at the 1, and then it will decrement its count to 1. So it will come here, it will decrement the count to 1, and then it will move ahead here. Okay, and then we can start with the b counter. So our start will point at b, and then so so as soon as we found, okay, and one more thing I forgot to mention, as soon as we found out that there is a duplicate, then this is the maximum number of substring that we have identified, and then we keep on searching. Then this b is found out, then the next one would be this one, um, and then we go on and so on and so forth. So I hope you get the idea of it. I was not quick enough to explain about how this would be traversing, but I hope the idea is clear. Now let's not waste more time on the explanation part, and let's dive deep and dive into the coding part. So let start is equal to 0 and end will be also pointing at 0. So while start is less than s dot length, we have to continue this loop, and then we have to send the length of the maximum longest string, right? So we can have max substring length to be equals to 0 initially. And then what we can do is see and have a let map is equal to new map. We'll have this map and then check if and let's say we'll take current character, current c char is equal to s of start. So we'll check if map dot has this current char. If it has the current char, then we will map dot set current char map dot get current char plus 1. We'll do that, and then else if it is not present, then map of current char will set to 1 if it is encountered for the first time, and if let's say map dot get current char is greater than 1, if we identify it to be greater than 1, then we found at that point we have found the largest substring. Then we can update the substring max substring length is equal to map dot max of max substring length and start minus end. Okay, and what we can do is if we have to subsequently decrease the count of if map dot has current char sorry, we have to let end current char is equal to s of end. Then if map has the end current char, then what we have to do is I was thinking about if a current character length goes to 0, then what should we do about it? Less than 0, should we delete it, or what what should be the plan of action? And we can keep it as is, right? Like if map dot has current char, then map dot set end current char, map dot get end current char -1. Okay, so we do that, and then do n plus plus. As soon as we come out of this, then do start plus plus, and we return max substring dot length in the end. And what if we don't get the max count till the end? Like no, there is no repeating strings. Then I guess we have to also check max, do the last check here, so that we have the max. Okay, this is accepted. Okay, we were able to do this. Okay, 2022 last solved, and this is 2023. Okay, after 1 year. Cool. So what is the time complexity of this? Time complexity in the worst case, we are talking about of n square. In the worst case, let's see what time complexity it says about it. And max would be of n, space complexity of, okay, this is of n cube. Sliding window of n square, it should be twice by ing. Yeah, in the worst case, each character will be visited by ing. By that they means left and right, right? So okay, yeah. So 2n of n is the worst case. Each character will be visited. Okay, space complexity minimum of mn. Space same as the previous approach. We need O of k space for the sliding window, where k is the size of the set. The size of the set is upper bounded by the size of string n, and the size of character alphabet m. Okay, this is good. Off in, off in selection. Okay, that's it, guys, with this one. See you in the next stream.